So we're down to chapter 4. Oh, I should mention, by the way, there is a hacking workshop tomorrow and the next day. You can come here, and they're going to do Hack the Box, I think, or Try Hack Me projects. So you might want to come to that. That's worth extra credit in any of my classes, and it'll also be where people can see what it would be like to be on the cyber competition team. So that's available for anybody. What's that?
Is it in the lab upstairs?
No, it'd be here on Friday and over in the Harry Britt building on Saturday, because this building will be shut. Good. And you can sign up there and you can read more information about it there. So let's look at the mapping the application. So first, one thing you have to do early is you have to enumerate all the application's content, all the pages, all the links, all the features, and some of them are hidden. And you might have trouble finding them all. So what you're hoping to find here is the attack surface and the vulnerabilities. The attack surface is all the ways attackers can send data into it. All right, and so to enumerate the content, one way to do it is web spiders. This is what search engines do. What they do typically is they load the HTML of the page, they find all the links, and they follow all the links. And then they follow the links on those pages and so on to whatever the maximum depth is. And the way you find content that is linked somewhere. This leads people to believe falsely that if you put a page up and you don't put a link to it, nobody will find it. And that leads to the very common flaw called insecure direct object access. A lot of people do this. It used to happen all the time that college teachers would have like their private grade book up on the web server, but no link to it, and think nobody's going to find it. In fact, and what you find out really fast is Google will find it. Google has a crawler that they made that is incredibly good at finding everything. Just because they have a huge list of all the common names and they try names even when there's no link. If you put anything on a web server that's viewable by the web users, Google will find it pretty soon. And that was one of the many flaws that I saw happen a lot years ago. Haven't heard that much lately, but I think maybe people have finally learned you don't put anything on a public server at all if you don't want people to find it. All right, so web application spiders also parse the, now if you have an HTML form where you have to fill in something like a login or address to purchase something or something, then your automated spider has trouble getting through that. So one thing they can do is try to fill the forms with random values and try to get through, but usually that'll fail because usually the form will require you to put in a validly formatted phone number or a valid password or something. They can also look in JavaScript to find links with things that are other than Ahref links. There are other kinds of links you can have. And tools like ZetaTrack Proxy is a scanner free from OWASP, and that'll do this. Vulnerability scanners will do this. Now, robots.txt is getting a lot of press now. Robots.txt is a file you put on your server to tell all the automated processes where not to go. There is no enforcement of this. It is sort of a matter of politeness, and the more professional companies will obey it. Now, right now, the AI companies many of them completely ignore this and scan all the secret stuff, and people are trying to sue them and demand money. And in fact, there's a new project that just started where they're going to put something in the robots.txt that somehow specifies the price and says, if you AI robots want to crawl our stuff, here's how much you'll have to pay to do that. This is just a new idea. Everyone, and Cloudflare has recently said they will give you a protection service. They will block all the AI bots from scanning your site, because everybody is currently very upset about this. Now, before AI, you wanted the Google bot and the other search engine bots to crawl your site, because if they did, then you'd appear in search rankings and a bunch of people would visit your page, and then they'd see the ads and they'd see your product and maybe buy it and all that jazz. And they said at that time you would get, I think every time you got scanned, you used to get scanned like 8 times for every real visitor or something like that. But now AI, they take the data from your site, they train an AI. All the users do is look at the AI. They never go to your site at all. So they say, now you get scanned like 20,000 times per real visitor. And that means the web will die. Nobody will have any actual traffic going to any web pages at all. They'll just be using AI. And the only thing that actually views your site will be AI robots, which are never going to see the ads or buy anything. So there's no way to pay for any services on the web. So it's a big issue. Anyway, robots.txt has been around for a long time, and that is one thing to know. And it is something that pen testers use, because you look at where they don't want you to go, and that's probably where the goodies are. So in a way, it's flagging where their stuff is. All right, So automatic spidering will find the stuff that's easy to find, that's right there in links, but it'll fail to find dynamically created JavaScript menus, links buried in things like ActiveX and Java, and in the old days, Flash. There are various kinds of links that your spider won't use, so spiders will not find every page on a site. And forms, like I say, might want you to have properly formatted telephone numbers, email addresses, and so on, and spiders usually can't successfully fill those forms out well enough to get through. I noticed this myself. This is how I got involved in Android security auditing. There was a report from Carnegie Mellon, I think, saying they scanned every app in the Google Store and they found all the apps that broke HTTPS by not validating their certificates, and they published a list of them. And I went back and just looked at some of them to see if they were still vulnerable, and then I looked at ones that were not on their list and found they were vulnerable because they made an automatic scanner, which was very dumb. And when I went in testing it manually, actually filling in the forms, I was able to discover vulnerabilities that they couldn't find. And that's the general case. So an automated spider, the good thing, whenever you do a pen test, you do both an automated scan and then you do manual scanning because they serve different purposes. The automated scan will really click every page and follow every path. The manual scan will be more intelligent about punching through the barriers to get to the interesting stuff. So you have to do both. They reach different parts of it. So spiders only fetch each URL once, but there are some applications which use the same URL for many different purposes. And even worse than that, there are some applications that keep changing the URL for the same page. They place volatile data in the URL, like the timestamp, so the spider will think it's a different page every time and load many, many copies of the same page. So, these are the limitations of an automated process. Now, in general, you should give your spider valid credentials. You should create an account and give it the right name and password or an authentication cookie so it can reach the authenticated part of an app. Otherwise, you're only going to see the surface. I mean, if it's an app where people can normally make accounts, inside the authenticated part is where most of the good stuff is. However, spiders often accidentally break their way out by clicking on a logout link or so on. All right. And here's a fun fact. If you log in with administrative privileges, the spider will click every button, including delete user, shut down database, restart server, and all that good stuff, so it can destroy your application. So that's another limitation of automatic spiders. All right, so user-directed spidering is another preferable way where instead of the spider clicking every link, the user opens it in a browser, going through Burp, and you click the links and it's recording all your traffic. So you control where it goes, and Burp just records everything as you go through. That's another way to do it. So you can open the browser in Burp, and then go here, and if you add it item to a cart on Hackazon, and to purchase a couple items, then you'll see, let me get down here, there. What you'll see, it'll build up a site map like this, listing all the parts of the page it's been to, and you can even see the user container down here contains login, password, and register, because I haven't logged in yet, so it contains only a few items. And if you log in, then you'll see more items. Anyway, if you log in, then you'll see other things here. So that's the kind of thing. This is what you're building if you want to build a map. You're building this sort of map in Burp. All right. And so let's take a look at a Kahoot about that stuff. Here, if I can get past all these stupid ads. For A. There we go, 4A. Anybody still coming in? No howls or protest? All right, I'll give another measure and then start. All right, so what tool finds every page in a web application? All right, you could say that, Spider, that's the intention. It doesn't always find every page, but it tries to. All right. It's probably the best of the available answers. All right, what part of a website might have validation rules? Typically, you put it on forms. You put client-side validation so you don't waste your time trying to process data that doesn't even pass simple sanity checks, like the zip code should be 5 digits long and so on. All right. Which feature is not a problem for a spider? Yeah, that's the reason why you use them is many pages. It'll go through all the pages, no matter how many they are, which a manual tester would get bored with. The rest of these things are problems, but that's the virtue of it. It really will load every page that it can find. All right, what risk is there if you spider while the administrator? Yeah, that's probably the main risk. Although these others are interesting, you wonder if the administrator could actually do shopping and stuff. I would imagine maybe they can't. And this one caught my attention because I was just teaching a private class as consulting for a corporation. And I was teaching about the OWASP Top 10, and I blithely said, everybody's going to two-factor authentication because there's all these attacks against passwords. And I asked them, how about you? And they said, we're not using any two-factor at all. And they were sort of embarrassed, and I was sort of worried. But anyway, that's an issue. This is becoming more common, that at least you make your administrators do two-factor authentication, and you really should make everybody do two-factor because it's so many ways to find a password or cheat a password. Anyway, but the main thing is, of course, that the spider may do something that the administrator can do that you don't want happening, like deleting the website. All right, so how do you use burp to examine an HTTPS request? Yeah, you configure your browser or your operating system to accept the burp certificate. Burp makes fake HTTPS certificates that will not pass the validation, and you tell your browser to trust them. And then you can have HTTPS traffic go through burp. All right, what burp feature stops all internet traffic? Yeah, that's intercept. All right. As you know, one of the early steps is to turn intercept off. If it's on, let's go back to here. You know, I used to demonstrate this stuff live, but I haven't bothered this time because I never really use this. And even in the Web Security Academy, you don't seem to use it much, so I'm not going to worry about it very much. Anyway, I guess you have to do it in a real pen test of a real site, but all the projects we're doing aren't that complicated, so you don't really need this whole chart of locations. Anyway, so user-directed spidering, the user's controlling it so they can go through complicated things like entering valid data in the forms, and they can also have enough sense to avoid the dangerous things that you don't want to use, like deleting things. Chrome developer tools will let you examine requests and even modify them without using a proxy like burp. You can examine them. It can be quite useful. You open developer tools in a separate tab, and if you go to the network tab, you can see every request and response just like you see them in burp. So that's often useful. Burp is more powerful, and that's mostly what we're going to use, but sometimes you can do a lot with the developer tools also. And one thing you can do with the developer tools, which Burp does not do, is it will show you how long it took to load every component on the page, which is commonly an issue for developers, trying to make your page so it will load quickly even over a slow connection, and trying to figure out which part of your page is causing the most delay. So, it's a useful feature for developers. Right, so finding hidden content. Like I say, automated testing and manual testing both help, and luck helps. I was once doing a pen test on a website at a request to the owner, and I got in immediately, and they said, "How did you do that?" I said, "Well, I noticed that the login page was login 2. So I looked, and there was something called login 1 that was really insecure." So that kind of thing tends to happen. Anyway, you'll find test or debug features left. You find different functionality for different types of users. You often find backups of the whole website in like a zip file somewhere, and in there you find the source code and so on. These are common things that let you in. And if you go to this workshop on Friday and Saturday, you'll be doing try hack me stuff, and this is often what you do. You get into a server, and then you find like a backup copy of something, or a log of the keystrokes. That's another thing you commonly find, the keystroke log on a bash console. That happened one time during CPTC. We had the penetration testing contest, and the images they were all hacking into, they forgot to erase the bash command history, so everybody looked there, found like the main administrator password right away. So it was very easy that year for everybody to get in. These mistakes happen all the time. Anyway, that's your backup archives. Another thing is default functionality. Microsoft's Internet Information Services, their web server, used to ship with a bunch of example scripts that were insecure. So people that forgot to remove them, there was a backdoor to get in, and so on. You might find configuration files, and unfortunately, you will often find credentials in files you can find. Often you find credentials on GitHub or other places. This is how a lot of hacks happen. They find a key or a password just lying around somewhere, and then they get in. Comments in source code may contain passwords, and log files may contain passwords or session tokens. All these things happen all the time. I read a lot of security news and do a lot of news podcasts, and it seems like every week or two, there's another one of these incredibly simple things that happens. The biggest breach in history was apparently the new one through the AI customer service platform, Sales Loft. And that apparently ultimately came from one developer. No, that was the Node.js. Sales Loft, they found an API token somewhere. They found one API key, they got in the Sales Loft, and once they're in there, they could harvest more keys from everybody's Sales Loft Salesforce instances, and they got in hundreds of companies. The damage is still coming out. Every company, every few days, another bunch of companies admit that they were hacked by this means, because once you got into their sales chat with customers looking for customer support, there were secrets in there, API keys and passwords. So it's a lot like when you get in the email. You'll probably find secrets in the email, passwords and stuff. Right, and then of course there's brute force techniques, and like I mentioned, this is I think how Google does it. At first it clicks every link it can find, and then it just tries a whole bunch of common names for directories and files, and there's a lot of tools that do this. If you're using Kali, it's dirb is one of the common tools that does this. An older one is called dirbuster, just a tool that tries hundreds of common names for files and folders. It's one of the first things you do on a website during a pen test, is run dirb to see what they've got. Now, Burp has a brute forcer, which you'll use quite a lot in the projects here, where you can give it a list of any words and you can tell it to use it in requests over and over to break into websites, to break into logins, and so on. Now, here's a picture of Derby. It's included in Kali Linux. So it just tries a whole bunch of things: account, admin, API, blog, contact, just a bunch of possible names, and it tells you what it found. The 302 means it redirected somewhere, 401 means it didn't find it, 200 means it found it. So it found a page called contact. That's why it quickly scans the site and tells you where to look. All right, let's try another Kahoot for B. All right. No comments in the chat. Okay. All right, I'll wait one more measure of the song here and then go in unless somebody else shows up. All right. All right, so what tool shows the timing of a page loading? Chrome developer tools. A useful feature of them to make websites more efficient. All right, which tool is ineffective in its free version? Burt's Brute Forcer, you'll find out when you run it. By default, Burt's Brute Forcer tries the first 10 guesses fast and then it slows down. So it takes a few minutes to give you even 100 guesses. By the way, if you learn some Python, you don't really need Burp at all. Everything Burp does, you can do with a simple Python script. And that's why I never paid for the pro version of Burp. But anyway, professional people, pen testers do use Burp. It just makes it easier to find all the tools you want. But everything in Burp is really doing simple things you could do with a little Python script. Anyway, that's Burt's Brute Forcer. That's how they try to make you pay. You can't really guess thousands or tens of thousands of guesses for anything without waiting forever, unless you pay for the pay version, or you just write your own Python script. And how do you find all of a website's hidden content? There's no way to do it. All these techniques find some of it, but there could always be more. The backup files might give you every page in a web app, but there might be other apps, and there might be more pages in the current version since that backup was made. There is no way to ever know you found it all unless you actually get root on the server and just copy the whole hard drive or something. I suppose that would do it. Anyway, none of those tools can do it. Whoops. Got to get back to, where is it? All right, I'm in trouble. Somewhere is the, somewhere it's gone. What's going on here? There, okay. When it's full screen, I tried to get back to it. Good. So William won twice. And Shoppy. And Jeffrey. All right, good. All right, we're still got time to continue. So, all right, you can also infer from published content. So if you find something called forgot password, like a script, then you can try add password, get password, reset password, that sort of thing. Like I say, once you get an idea what their naming convention is, you can maybe guess what the name of other objects are. Same thing applies for guessing the usernames of people at a company. Like at City College, it's the first letter of your first name and your whole last name, and most companies have some pattern like that. So names might use numbers or dates in them. You look for the include files. You'll find many files. If you right-click on a website and go to inspect, you can look at all the files that are making up a page. Comments may include information, and Java applets and ActiveX control might have useful information in them about files. Temporary files created by tools and editors might help. Mac creates these DS store files, and when you edit a file in an editor, it often creates a temporary file of the old version of a file with a -1 on the end, and so on. And those often contain secrets. This, by the way, is why you have Microsoft BitLocker. Before Microsoft invented BitLocker, which I think came out in Vista, they had an encryption feature that would encrypt the contents of a folder. And what they thought is if you go on a Microsoft system, it's C user's username, and in that folder is your desktop and your documents and your photos and everything. So they thought encrypting that one folder would be enough to encrypt everything, but then it turns out that when you're using Microsoft Word and many other applications, it makes temporary files outside that in like C temp. And so they found out that even when you encrypt your entire profile folder, in practice, your secrets are in other files hanging around outside, and the only thing that will actually protect your secrets is to encrypt the entire hard disk. That's why they switched to BitLocker folder drive encryption. It's the only thing that means that if you lose your laptop on an airplane, you don't have to disclose that as a breach because everything was really encrypted. And encrypting just your user folder doesn't really provide that feature because under normal conditions, those temporary files are deleted, but they're not really erased from the hard drive. And also, if the operating system crashes or your tool crashes, then the temporary files are left there. All right, so Burp Pro has a content discovery that will try to go in with a list of common files and directory names like dir and try to figure things out in Spider. It has a lot of these features in the Pro version. And by the way, you can get like a 90-day free trial of the Pro version. And in the Web Security Academy, some of them require the Pro version, and you can use a trial version if you want to do that. I never bothered. I just used the free version. But, you can do that. Skipfish is Google's scanner. They made it open source, you can run it, and the main thing it does is it really vigorously finds all the files and folders. It's really fast at that, as you would expect. That's Google's main use. All right, and there's public information, things like search engines, web archives, posts to forums like Stack Exchange. These are all places you could go to find out what's going on at a company and what sort of resources they have. And Google Advanced Search. You can specify the site and search only within a site. You can look for the word login on the site just to find the login pages. You can look for things that link to the site. You can look for things that are related to the site, and all these are helpful to track down things. I've done this a lot when these things are called Google Dorks, things that find vulnerabilities, and you can often find passwords just sitting on the web, old versions of login pages that have known vulnerabilities, and so on. Find pages that have SQL injection. In fact, we should try one. There's a hilarious one, which often works. Let's see if they've actually fixed this. You look for in URL, select from. I think that might do it. Yeah, and what I found usually, when I used to do this before, I didn't have to go more than a page or two before I would find a page that actually used inline SQL in the URL. And maybe this is not so common. When I first heard about this, people said, when you see this, you just want to give up security and just go cry in the corner, because if people are going to do things like this, then you're, okay, I'm not finding one anymore, which is nice. But what I found before was like a sports shop selling things, and it would just have company.com, and then it would say select shoes, select item from product where type equals shoes. So you could just type select commands up there and execute them on the server. It isn't even command injection. There was just a command right there, right in the URL, that you could just send commands to the server. Now I'm not finding that quite as often, but there are people that have no idea what they're doing, that set up websites, with just ridiculous functionality. All right, anyway. That's an example of a Google dork, and there's a lot of them. So they're web servers that let you see directory contents or raw source code. It's a configuration on your web server, like your Apache server, whether you're going to allow me to do a directory of see all the files in a directory, and you should turn that off, of course, because there are probably files in there that are not intended to be public. And there are often mistakes that expose the source code. Now, if you have a PHP page, like a login page, I'm only supposed to see the output of the script. I'm not supposed to be able to see the source code. But there was a version of Microsoft's IIS again where you could just put :data at the end of the URL and it would show you the source code. And now everybody keeps putting their source code on GitHub and often making it public, so you can often find the source code somewhere. And people keep putting hard-coded secrets in the source code, which is one of the OWASP top 10 mistakes not to make. And so, the source code often helps you. Nikto and Wikto are the Linux and Windows version of a very simple vulnerability scanner. People always recommend it, but I must say, I've never learned anything of any use from this thing. This thing just tries for common vulnerabilities. It always tells me very simple things like Apache is out of date, but I've never learned anything very useful from this. It is recommended, but I've yet to get any good out of it. But people often run it. Anyway, then you have functional paths, like I say. This is another possibility where you go to the same URL all the time, bank.jsp, and all the parameters specify a different function. So this would confuse your spiderer. It would just load one copy of bank.jsp and think that's all there is. So this is a very different structure to explore than the kind that spiders are designed for. If you go use Z-Attack proxy, there's even two versions of the spider, one for old pages and one for the new pages using the modern JavaScript frameworks like Angular and such. So you make a map of the functional paths. You got a login, you have home, then you have transfer funds, bill payment, confirm payment, enter amount, and all that. This is what you want, is to draw a functional path of how the data passes through all the functions. And then try adding parameters to it, like debug or tests or so on. And Burp Intruder can do this. We'll do this kind of thing in the projects. And you can look at the key areas of the page, core functionality. Usually the core functionality of an app does not contain terrible bugs because they would notice that. Usually the peripheral place is where you really find the goodies, something that's not used very often, like the password reset function or some connection to some other app that's not used very often. Like one of the things that happened a few years back is it turned out that all the Amazon cloud servers were vulnerable through the driver on the virtual floppy disk. And nobody used the virtual floppy disk anymore, but it was just hanging out there. And people found out, of course, that code was old and neglected. This is what tends to happen. Also, redirects are important. If you can somehow specify the next page it'll go to when it's done, then you can use that to point to an unusual place and sneak in there. That's called server-side request forgery, where you trick the server into going to a different location than it should go, and it's often allowed to go there, even though you wouldn't be allowed to go there. It's an internal process where their internal server is going to another server inside the company, so you can often redirect your traffic through a server's redirect to reach areas that you were not supposed to see. All right, and check of course, the fundamental thing you always got to check is authentication. How do they maintain session state, and is the access control working? As I've said many times, it seems to me almost all the time that when you map out the API, there will be a couple of dozen endpoints, and some of them will not check authentication. People just add more stuff, and somebody makes a mistake. It keeps on happening over and over again. You can do something that you really should have to first log in as administrator to do, but that function is not enforced. And again, it can be that way for years, and nobody will notice because it works for normal workers. They won't notice that you could also get in without logging in. All right, so any place it handles user input is where you're likely to find a vulnerability. The URL, the query string, the data in a post request, the cookies, all these other things like form and Java applets and so on. Anything that feeds data into the app is a possible way to sneak in attacks. And all your server-side technologies matter, the interaction with databases and other software on the server. These specify the sort of attack that might work. So you see all these entry points, URL, parameters, cookies, all the headers like user agent and referrer, all those header fields might be susceptible to various injections and other attacks. And the RESTful URLs, remember, it'll take parameters and put them in like they were directories. Shop, browse, electronics, iPhone. These last several items are in fact parameters, not directories, but they look like directories, so it's a thing to know. And then normally the simple structure would be like this: google.com, Q equals duck. This is the query string, but you can put it in non-standard ways. You can have semicolons separating several parameters. You can put it in a file and then a slash. You can have the parameters here and then the file afterwards and so on. It's kind of crazy. In a sane world, they would have picked one format for a web request and stuck with it, and that is not what happened. There's just dozens of different ways to feed the data to the server. In principle, you can feed the data in any structure at all. There's a script on the server to parse it. And it's just kind of a mess, like so many things. There are many, there's an XKCD cartoon about this. They say there's 14 incompatible standards. This is ridiculous. We'll make a new standard that covers all use cases. So they do that, and now there's 15 incompatible standards, and that's what happens on the web. That's why there's so many movie formats, so many image formats, so many web request formats. Everybody keeps inventing new stuff all the time. All right, so user agent is used to specify what you're using to browse, typically the name of your browser. And the main thing it's used for these days is to tell whether you're using a desktop machine or a cell phone. Because if you're using a smartphone, I want to serve you a different page that's designed to fit on that small screen. That's the main purpose. So changing the user agent may give a different user interface, which may have different vulnerabilities. And X forwarded for might be used if it's behind a load balancer. Then it will keep track of which actual server it's going to of the many available servers. And there are out-of-band channels other than web requests like email, figuring out how to publish from another server. Like web dev is a process where you put something on a server and it automatically uploads to the web server. Developers set this up. There are IDSs that are sniffing traffic and putting it in some log file, which is then viewed over the web. So you could send traffic just to get caught by the IDS, just to go in the log file, to sneak in bad stuff. And like I said, there will be API endpoints for other things like cell phone apps that typically connect to API endpoints that may not be used by the web app, but they're another way to sneak data onto the server, which might be vulnerable and give you control of server functions. So let's try another Kahoot. All right, which is C. All right. There you go. You might be able to name yourself Kahoot admin and gain privileges. That's a perfectly fine thing to test. Sometimes I see students putting like JavaScript injection in these things and stuff. Still shows the right attitude. Anyway. All right. All right, so what file is created when you edit a.txt? Okay, yep, a.txt-1 is one format that would commonly be used for that. Which system might put data sniffed from the network packets into a web app? Yep, that's your intrusion detection system. All right. Which header may expose private data from one website to another website? The referrer shows the URL you came from, and if there are URL parameters, including secrets, they're exposed to the next website. That's why one of the many reasons you're not supposed to put sensitive data in the URL. It should be in post parameters, not in URL parameters. All right, what vulnerability scanner runs on Windows? That's Wicto, is the Windows version of Nikto. It's fast and easy. I just don't find much use in the results. All right. Oscar. Jeffrey. Good. All right, well, it's coming up to an hour.